Ladies and gentlemen, welcome back to another live stream. So in this live stream, we're going to be doing something very interesting. We're going to be creating a voxel engine, live coded. Obviously, I've created like a Vulkan render like 1,000 times at this point, So I know a lot of tricks when it comes to Vulkan, when it comes to CMake, when it comes to SPIRV, when it comes to C++, when it comes to all sorts of things. So obviously, this is not someone who's just like vibe coding this, just hand wavy. This is somebody who at least kind of know what they're doing. I mean, Vulkan, to be honest with you, you never know what you're doing. At least for me, it might be a skill issue. But still, overall, compared to someone who doesn't know Vulkan, I'm pretty well positioned, I guess. But yeah, anyways, live. Let's go. All right. Yeah, okay. So they're going to be using modern Vulkan extensions. They're going to be using great libraries that like tutorials wouldn't otherwise teach you. We're going to be teaching you also some great like good CMake stuff, etc. But yeah, either way, pretty cool stuff. Let's go. I think yeah, great. So everything's good, I think. Yeah, all right. Let's grab the chat here. And let's get started. Let's get started. Alrighty, so I have all my tools here. So obviously you just gotta make sure to install the Vulkan SDK. Just like this, or Linux, or whichever. Linux, obviously, though, you gotta use your own package manager. Mac, maybe you even use Brew for that one, I'm not sure. Either way, once you got your Vulkan SDK, you gotta make sure to come here and make sure you go here to your Vulkan SDK, run this maintenance tool, because we're not going to be like downloading libraries. We're just going to be using the ones that is bundled with the Vulkan SDK, so we don't bother with that and we don't add compile time, etc. All right, so you just go with the first option. Here I have the menu in French because I'm in Morocco, but whatever. And you're just going to say next, and then you're going to find these guys, right? And as you can see, it gives you the option to actually include GLM, SDL, Vulk, shader toolchain, etc. Make sure to include all of them, right? For example, for me, I'm not going to be cross-compiled to ARM64, so I could theoretically like disable this one. The other ones, though, I'll need them 100%, but yeah. All right, but just to be sure, just say all and get it together, and that's it, done. All right, cool. Okay. All right, so once you're done with that, you're gonna find that in the Vulkan SDK, you got binaries, like you got the shader compiler, you got all sorts of things, right? You got even slang compiler and so on. You got vkconfig and vkcube, so you could test if you have your Vulkan setup. So is my live stream live, by the way? Is it public? Let's see. Let's just make sure. Let's make sure. All right. Yeah, it's public. Okay, cool. Lovely. All right, so yeah, that's basically that. Just make sure you have these. I'm gonna be using VS Code, but you could use whichever the heck you want. You could use C-Line or whichever. All right, so let's just get started already, actually. So we're gonna be first of all creating some sort of I don't know, like some folder. And let me just go here, I guess, and just create a new folder, and let's call it dev, I guess, or projects, whichever. And let's just create a folder and let's call this something. I don't know. Let's call it Codochario. Why not? Coming from kind of like Factorio. Anyways, and we're gonna open this with code, and we're gonna trust this workspace, and let's get going. All right, so let's see. Where do we even start here? We're gonna open or add projects. Gonna come to projects, go to Chario. Obviously, you gotta make sure to install CMake and install Ninja. If you're on Windows, then you just go ahead, look for Ninja. You know, you're gonna find ninja-build.org, right? And then you just download the Ninja binary right here. And afterwards, you just get an executable and you basically add it to your path by just adding it into the environment variables path. And then as you can see here, I put it inside of a folder called bin in my C here. Where's bin? There you go, bin and Ninja. And as you can see, I just put the folder bin in here, so it's in my path. So right now, if I go to my terminal, then I say ninja dash version. There you go, and cmake dash version. But yeah, otherwise, obviously, you gotta also make sure to have Visual Studio Build tools. So just in case if someone wanna follow along and they don't understand how to set these things up, just giving you a little primer there. So obviously I'm using Visual Studio Code, and you could just come here and install the build tools and just select C++ from there, and you're pretty much done. All right, and with that, we got our tool chain ready. As for VS Code, here's my settings if you're interested. Open user settings, so nothing fancy. I just have format on save, so it saves automatically when I save, and it got mouse wheel zoom, so I'll be able to zoom in and out. And I'm using the JetBrains Mono font. You could download it pretty much and install it. And font ligatures, so when I say equal like this, it does that, or like this, and so on. But yeah, and font size 20, and finally the CMake generator Ninja. And for the extensions, I'm using error lens, so it shows basically the errors inline, and the CMake tools obviously for CMake stuff, and the CMake IntelliSense, so it does give you some IntelliSense. Now obviously make sure it's from Kylan IDE team, because the other ones that you're gonna find on the store, on the extension store, are most of them are like not like updated anymore. Make sure that they're updated. For example, this one is last updated 3 hours ago. And instead of the default C++ one, I'm just using ClankD directly. So the ClankD is way better because it's actually using a real language server, and this one was just installed for whichever reason by VS Code anyways. All right, so yeah, let's get started, I think. So let's go to our open code here. I'm going to be using a free model, which is Big Pickle. All right, and let's create a new session here. And first of all, I'm going to ask it to basically get familiar with my environment. So research my environment, find the Visual Studio Build tools, like vars, bat file, also check CMake and Ninja version, and check the SDK, the Vulkan SDK. All right, let's get started from that, I guess. So just making sure that it understands my environment pretty well, because otherwise you're just gonna keep on wasting time on trying like errors not finding the compiler or whichever. And there you go. Cool. Also, so now okay, check my NVIDIA card and my Vulkan extensions. So obviously it needs to like run a command in there that gives it all the extensions, as you can see. All right, cool. All right. Pretty sick. So now it kind of got familiar with my environment. Check which libraries are been bundled. Check which libraries are bundled in the Vulkan SDK. And there's CMake configs. Hello, Box and BG. Welcome to the live stream. Welcome back. Let's go. All right, so I'm just making it sure that it probes my environment very well first, so we could get some context. And yeah, look at that. It already understood the assignment. Okay, cool. So now I'm gonna tell it what we'll try to do. So I wanna make a Minecraft-like voxel game using Vulkan 1.4. Wait. 1.4, C++23, and SDL3. The latest extensions that my card can support. Alright, sick. Now identify the extensions we can exploit. I have a challenge for you, sure. Okay. Make a VR game in C++ for 3 days. I don't have a VR headset though. That's the problem. I would have probably tried that already. But you would use multi-view in Vulkan for that. That's the only thing I could tell you about VR. Yeah. Alright, so based on the RTX extension list, here's what exploitable for a voxel engine. And there you go. You can use a sim. Oh, really? I don't know about that. I'm not familiar with that. But yeah. So we got dynamic rendering shader objects, extend dynamic state 3, push descriptor buffer, buffer device address, geometry generation, GPU side voxel mesh generation, emit triangles directly, no CPU side meshing. Accelerate BVH for voxel ray marshing, global illumination, path traced, ray query, invocation, reorder, mesh shader queries. So obviously, as always, the first step is research. Okay, so cooperative matrix. So cleaner barrier model, okay. GPU sync for async chunk meshing. GPU driven chunk data copies. Calibrated frame timing. Visual quality. Particle system. Mesh shader. Procedural geometry. Custom MSSA patterns for voxel edges. What? Flash heating control. Video and streaming. Okay, and debug and profiling. All right, sick. Sick. All right, for now we'll stick only. For now, let's just stick to dynamic rendering only. We'll start by creating a triangle. Obviously using, actually not even a triangle, just creating a clear screen. Or not even a clear screen, just an SDL window. Yeah, let's start very freaking small. So generate CMake file and CMake preset in this directory. Use modern CMake patterns and use the library configs in the SDK. All right, so I think that's it. Tell me how you plan to do it first. All right, so configure presets, MSVC, Ninja Generator. Find package Vulkan required. All right, cool. Okay, so this is a mistake it made here, which is linking Vulkan. This would link the Vulkan loader, which is not what we want. We want to link a Vulk instead. Set C++23 via target compile features and VS generator plan presets no wall noise for now. Initialize SDL through the SDL init video. Create SDL window Vulkan. Query required. Okay. Does the plan look good or do you want any change before start running files? Look good now. SMSVC. Okay. So add src include split from now. That's the first. Also use latest CMake version that I have instead of CMake 3. And what else? Also don't link Vulkan, that's the loader. Link Vulk instead. Yeah, I think that's that. Anything else I've noticed? Not really. Later on, we could like split stuff up, but for now, we're just gonna, like do everything in one single file in the main function. Later on, once we got something working, we can start extracting patterns. Like when we see there is some pattern, then we could start extracting into its own class or function or whatever. But we'll keep it dead simple until we actually need the complexity. Instead of falling into the trap that I've fallen into several times as a beginner, and yeah. Don't try to like abstract Vulkan. I thought, by the way, about like using Vulkan HPP and Vulkan HPP RAI, but it just bloats compile times a lot. It adds some a bit of overhead, not much, but a bit. And also just kind of makes a mess of you having to constantly juggle between RAI handles, HPP handles, and raw Vulkan handles and so on, which kind of suck. And RAI in general is kind of, I've never really liked it. I don't know, it's just a lot of magic, a lot of implicit stuff. Except for a few things, like for example, let's say std vector or whichever, that's fine. RAI is pretty good for that part, right? But for things that are very dynamic and have a lot of ownership crap and so on, it just sucks. You really need like explicit ownership most of the time. But anyways, so permission required, sure, allow always. This was something I've changed myself, yeah. I always mention this part because I was kind of proud of it. Like it was first time I contributed to SDL. So I was like, wow. But it wasn't really much. It was just that SDL for the Vulkan extensions, they were like actually like allocating a whole array for no reason. While the array was actually static per platform. So I just told them to just like return. I mean, I actually tried like basically made a pull request to just return the static thing, static array per platform. But yeah. Anyways, so what we got here, done, files created, blah, blah, blah. So, or release. Vulkan. All right, let's see. Let's see if it works. Did it got it from the first time? Let's see. Would it work on VS Code, or do we have to do some extra things? There you go. And boom, let's go. Required instance extensions, Vulkan 1.4 loaded, window created, Vulkan surface ready. Let's go, nice, lovely. Okay, so Vulk, no CMake packaging SDK, create import target, perfect, lovely. Wait. For Vulk though, I think there is like Vulkan Vulk, no? Yeah, I believe there is Vulkan Vulk. I mean, it's the same thing kinda, but still, I don't know. Wait, what? Oh, it didn't, I guess. Wait, find package. It didn't do find package. I see. Vulkan required, yes. And let's just, I guess, remove this part. How about now? Weird. Pretty sure it worked before. I don't know what's up. Or maybe I need to say like required components in Vulk. How about that? Ooh, okay. So you just say required components Vulk. So that's how you do it. Okay, cool. So right now I think we could probably say remove that thing and remove this part here. And also remove this part. So you just say find package Vulkan required components Vulk. Find package SDL3 required. And yeah, it would just, as long as obviously you have the SDK set up, you should be good to go. Oh wait, what the hell? Oh yeah, so maybe the header file right now kind of changed a bit. Let's see. I think maybe it became in like Vulkan/Vulk or something. I don't know. I mean, let me try to. Sometimes VS Code like LSP or like ClingD kind of sucks. So what you could do is you could say tell it to restart. Oh, is not found. All right, so install it, please. All right, cool. Now try to restart. Okay. Now, how about now? Huh. Vulkan.h or what? I mean, these ones, I guess, are visible now. Well, that's interesting. All right. Let's try one more time. I think we probably need to basically make it copy the... Yeah, all right. So let me tell us something. Can you make a VS Code settings, project settings file? Or wait, you know what? Let me just do it myself. Thank you. Let's just go ahead to settings. Right, and then you just go to extensions and CMake tools, and where that is build directory, there is like a copy command thing. Where's that? There you go, copy compile commands. And now I gotta figure out how to do that. Wait. How to set copy compile commands path in VS Code for CMake tools to the root project there. Yeah, and you just do this. So workspace folder compile commands.json. So this is a little workaround that you have to do to get it to work. Now, I guess let's try to maybe restart or something. Maybe let's try to rebuild even. And there you go. Right now it actually copies over the compile commands. And let's hope that works now. And yeah, I guess maybe it works now. Let's try now. So include, there you go. Look at that. Look at that beauty. Vulk.h. So in the SDK, if you're using the SDK Vulk, then you gotta change the include right here. As you can see, Vulk like that. And yeah, now if we try to build and run, and boom, good. All right, so I'm gonna tell it to read the code. I changed a few things. All right, so is there anything else? Yeah, obviously we don't want to return exit failure. Honestly, I would go, first of all, I would set up from now like the SDL callbacks really quickly. So we have something to start off from. Include order, vol class is fine since it's defined. Oh yeah, also another thing is the Vecino prototypes should go into target compile commands here. Instead, it's much safer that, there you go. So target compile definitions, could the target private, Vecino prototypes, so we could remove this thing, because if you mess up the order of this here, then you would be wrecked, right? So better to just do it in the CMake instead. And you should be good to go. Now, apparently we don't even need, I guess, the include vector there. And yeah. All right, so anyways, let's see what we got here. cd print line, stdl create window. If not window, then SDL quit, and SDL can get instance extensions, destroy window, quit. I mean, pretty nice code so far. Though, wait, there you go, cool. If vk create instance, voc load instance. Okay, voc load instance. How about voc initialize? Yes, you did it. This doesn't return. Okay, cool. All right, that seems great. All right, sick. So now what I'm gonna do, I'm gonna tell it a few things. So first of all, I'm gonna tell it to read the SDL3, what is it called? Oh, crap. Callbacks, yeah, main callbacks. I'm gonna tell it to read the README. Read this and tell me what you learned. Just making sure that I actually have read it. Alright, so I have moved the vk no proto define to CMake file, add the macro that SDL main callbacks needs, and implement it. So the foundation is always very important to go very slow, because that's where the AI start to kind of understand your style and your direction. But like afterwards, once we got a little bit of code going on and a few rules and context, we could be way faster than that, especially once we set up the GitHub, like Git thing too. But yeah, so all right, so all right, let's see what we got. So it made a window, an instance, and a surface. SDL app init, Vulkan initialize, state, new app state, a sick, SDL create window, okay, cool. I'm working on a vibe coded game on Cocos 2D called Coco Scratch, just Minecraft clone, but in Cocos 2. That's cool. How was it? Like, was it a smooth sail? Did you encounter some problems, or how was your experience? All right, so I think this is great. The only thing I would add is add an SDL exception, which just sets SDL get error as the message and throw it from on any Vulkan function fail instead of exiting. Other than that, what else? I mean, actually, SDL app failure is not bad, to be honest with you for now. Yeah. The one thing I would do is I would tell it to, you know, like link up the STD print line and stuff, the login and so on, the STD ouch to SDL essentially. But yeah, by the way, does this work in fact right now? Oops. Wait, what? What was that? Wait. Well, that was strange. Yeah, I don't know what was that. I've seen some like red things there, but anyways. Okay, so add an nah, no need. So just redirect like SCD CER and SCD Couch to SDL logs log error and SDL log SDL log priority, sorry, log priority. Oh, I pasted the URL and call. I see. And hello, Killer XDBR. Welcome to the live stream. It's new. You can search Cocos 2D and you can try and use an installment. What is? I thought like Cocos 2D is like for iOS, no? And like Apple stuff. Is it like cross-platform? I don't know. I'm not sure where I got that impression though. So yeah, it made a class right here that inherits from StreamBuff, which is nice. So basically, when that class gets constructed, the CEouch and CER of C++ gets redirected to SDL. So this would work out fine for you on any platform, whether it's Windows, Android, or whichever, which is cool. And when it gets destroyed, when this SDL log buff gets destroyed, it kind of reverts back the original ones, so you wouldn't have any kind of issues afterwards, I think, right? Let me verify that's the case. It didn't add though a destructor, which is weird. Yeah. Well, I'm gonna ask it. I think it actually kind of missed that part. I mean, it's not a very big deal, but could be a problem. iOS is Cocoa. Yeah, I see. Oh, so Cocos and Cocoa. I see. Build clean. All right, custom. Do you like revert the streams on this on like what is it called? On destruction? No, the original are lost. Let me fix it. Save them or restore. There you go. I was talking about a game engine. Okay, I see. Is that like a new game engine or because I was hearing about Cocos, but is there like a Cocos 2D, but there was like a Cocos 3D? Yeah, I have no clue about that Cocos engine, honestly. I'm not sure how does it compare to other engines like Unity and Godot and etc. Love 2D, libgdx. Oh, it's sold. So Cocos 2D, I see. Why did you choose it over the other engines? Cocos is pure. Okay, so it doesn't have an editor. That's interesting. All right. Did it add like the structure right now? Yeah. Why not just add the structure? But there's Cocos creator, but it needs your personal info. Cocos creator. Like, who's the developer of this engine? Like, who is it? Is it like a company or? Steal duplicate from the original code, remove it. Yeah, it kind of sucks. That kind of bited me along a lot of times there. Anyways, build clean, here's the final state. All right, so this is just a little bit of plumbing. So it kind of starts picking up on my style. It's not more like, it's not really about the extreme state is here exactly, but more about it's picking up on my patterns kind of. But yeah. And yeah, okay, so what else are we gonna do here? Make a destroy surface. I think maybe we'd better go with exceptions, or maybe not now. Fine. And there you go. It still works. Perfect. Okay, so what we're gonna say is make sure to handle Android like, I mean, we're not gonna be supporting Android generally, but still, just do it. Lifecycle with SDL events. We'll go to background and leave background, etc. Like, yeah, I don't know. Make sure to handle Android surface lifecycle with SDL events. Let's just see what it's gonna say, what it's gonna do. Bool foreground equal to true. And there you go. It checks if event type did enter background, then it does some few things there, and we'll enter foreground. Cool. All right, so I think right now we're ready to go into a clear screen right now with dynamic rendering. Or not even dynamic rendering. Let me just let it do the smallest Vulkan program ever written, which is basically just now implement a clear screen using VKCMD clear image and sync to. But wait, before that, hold on. Git init first. Really, git init, make a proper git ignore, then commit, then implement. Also, my, like, what is it called? My git email is this, and username this. Let's go. Because I just reinstalled Windows right here. And I just installed Git. Obviously, you gotta make sure to install Git too. Wait, did I actually install Git? Wait. I might have forgot it though. Oh crap, shit. Wait. I forgot, okay. Hold on, Git Windows. I have forgot. I like to always reset my system. I don't know why. I just love that feeling of like a clean slate for whichever reason. Especially if I experiment a lot and I feel like my system just became a mess. Wait, hold on. I'm sorry. We gotta first of all like install this. One thing though, make sure to override the default branch with main. And for the other one, just say next, 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 next. But yeah. Okay. I've installed also some debuggers here, as you can see. I've installed RenderDoc, Insight Graphics, and Insight Systems for NVIDIA. And obviously the Vulkan Caps viewer and Vulkan configurator from, what is it called? From the Vulkan SDK. But yeah. All right, so let's reopen open code now. And let's let it do its job. It should have right now get into its path. If only we could mind trace some people and install a debugger. Hello, Adam Rushford. Welcome to live stream. Right. Let's go. So we're gonna be using the Vulkan configurator to debug. So instead of like going through the pain of setting up the Vulkan layers programmatically, we're just gonna be using the Vulkan configurator here, using the validation layer. So the validation layer, basically, if you're misusing the API, it would tell you. Also make sure to like enable synchronization. This would also make sure to tell you if you're misusing synchronization, you have some problem with synchronization essentially. Other than that, also enable best practices, because why not? This would basically tell you if there is some better ways to do the things you're doing in the opinion of particular vendors, like for example NVIDIA or AMD or whichever. And even another cool feature that not a lot of people know about is this one. Like if you basically press this, toggle this, if there was like some error in your code, some Vulkan error, it would just break there. So if you had like a debugger running, it would just break straight into the line that the error happens. So you could theoretically, for example, write a program where you don't even handle any kind of like Vulkan errors at all, but then just use this feature right here and it would automatically do that for you, which is pretty cool. And obviously there's error, there's performance severity, there's warning, and there's info. We could go with all of them, why not? And yeah, and there's also the API dump. So the API dump is basically about, like, if you enable it, you would like print all the Vulkan API calls you're running or you're executing in your program, just like how it looks like from the driver side. So you will see the arguments that you passed in, you will see everything. It's pretty useful for debugging. And this is something that I really love about Vulkan compared to other APIs, graphics APIs. Now, obviously, like for example, a web GPU or whatever, I mean, they're running on Vulkan themselves, so you could definitely use this Vulkan configurator too on them, like SDL3 GPU too. But still, like when you're running through those abstractions, you don't get like a clean one-to-one mapping between those APIs. But when you're just using raw Vulkan yourself, you get like a one-to-one clean mapping. You know exactly which call it's talking about, etc. But yeah. All right, so what it did here, sync 2 times are all in Vulkan core, no extra includes needed. Let me set up Git first. All right, so that's sick. Write the Git ignore, sick, and edit the Git ignore. All right. Pretty cool. That's very noisy. You have to check for every single one. Now, I think probably like for Vulkan like stuff, you don't really need to check if it's not null or null. It doesn't matter. Like if you just pass in null, I think it's just a no OP. I could be wrong though, but I think that's probably the case last time I checked. So you can get rid of that staircase of if conditions. I really hate them. That's one of the reasons I don't like to use C, just for this particular thing, which is error handling. It's just infuriating, man. Oh my god. Anyways, here's what draw frame does each frame. Okay, let's see what it did there. CPU waits for previous frame, get next swap chain image. In define to transfer DST, clear to dark blue gray, transfer DST present source, and submit with fence signal and present. Alright, so both barriers use that. Swap chain squared from surface, prefer falls back to whichever is first, events recreate on foreground return. Alright, so we got this gigantic code already. Alright, well, let's see if it did a good job or not. So we got the window, the instance, the surface, and the physical device, the graphics queue family, the device, the graphics queue. It does need an extra one here, and it didn't add like, what is it called? First of all, does this actually work? No, it doesn't. Okay, so we gotta make sure to call it though. No suitable GP font, bro. What the hell? What the heck? Run it. It's not even working. It says like just no suitable GP font for whichever reason, which is quite interesting. I wonder what happened there. Okay, I already can see. I guess what's the problem here? Maybe wait. No, never mind. Well, actually, wait. Weird. But let's see. Bruh, checked its logs. But yeah, I think. Wait, shell. And let's see if it figures out. So slow, bro. But yeah, anyway. So found that the bug is comparing vacay against vacay true instead of vacay success. Bro, what the hell? Really? I mean, if it got that wrong, I don't know what the hell it would get wrong other than like, bro. Wait, what? No. Weird. And there you go. It got since we're basically are enabling the validation layers, now I could just set back and let it fix the issues itself. This is also something very nice about programming Vulkan. So like you just get very good like messages about what happened wrong. 3 issues found. Sync to feature not enabled on device. Swap chain image usage only isn't found for image views. First barrier should be matched in the wait stage, not top of pipe. Semaphore reuse. Validation warns about reusing. Perfect. So it just reads the logs, like the validation messages. It fixes the problems, and you're good to go. Perfect. Now fix draw image. Use per frame. Hold on. Let me go to VK Bootstrap. Triangle. Read this and mimic its sync. You see, because right here, I know for sure it's gonna get in a loop. It's gonna get stuck in a loop where to actually know which to signal, you're gonna need to. So yeah, there's just kind of like a feedback loop there, which it could easily get stuck in an infinite loop trying to fix this, and then it hit that and so on, which sucks. So here, essentially what you kind of need to do is like you have those two vectors that we currently have, but you add another third vector that just keeps track. It doesn't create like new fences or whatever. It just keeps track of the fences that are currently in flight. It just kind of like borrows them. It just tracks them, reference them, not really create new fences. But yeah, so really the swap chain crap is just so finicky. And honestly, I'm really debating using like a VK Bootstrap library. I just don't want to add much dependencies if possible for now. I'd rather keep myself only dependent on the what is it called? The Vulkan SDK, but yeah. Guitar Diary, welcome to the live stream. I'm from Morocco. Right main CPP. And since we're just linking to like to the binaries that exist in the Vulkan SDK instead of building the libraries ourselves, you know, the compile times, as you can see here, is just very fast, pretty much. And we're getting a black screen, but we got some validation errors, as you can see, which is nice. Like all the vendors are like shouting, that's a very unoptimized function. Use a render pass or, you know, whatever, like a graphics pipeline. But I'm getting a black screen. I wonder if it's that the color it's using, or is it like some problem? Well, it is using black, I think. So let's try to change that really quickly and see if we're gonna get red. And yeah, we are getting red. I wonder though if it like, you know, okay, so do you handle resizing currently? I don't think it does. I don't think. But it's a good thing, so we can progressively build this step by step instead of trying to do everything at once. Yes, go ahead and handle swap chain recreation. All right, if I had to rewrite, like write this myself by hand, I would have been stuck forever here. Oh crap, man. It would took me like at least 3 hours or 4 at the very least. Or maybe I'm just so slow at typing, I don't know. Now here the context got too big, so it's currently compacting the context. Because right now it's at 73%, but yeah. So notice I'm going very slow with the AI. I'm giving it very little milestones, just like I would have done myself if it were just starting off. I would, and not even like starting off, but just generally, if I was making the projects myself, I would go through this progression. I would start off by making, first of all, a window and make sure that it's working properly. Then go ahead and use clear color, just a command, just a clear copy command thing, and go to the next task and so on. And actually, it's not using currently the, what is it called? The in-flight frames, so we gotta add that too in a second, but let me just make sure it handles the swap chain recreation first. So yeah, it's nice that it made sure to use a dirty flag instead of just recreating the swap chain directly, which would have sucked. And one thing that a lot of people, beginners and even AI falls into, which is the reset fence thing, which let me see if it handled that correctly or not. Wait, where's that? Hey, what's going on here, bruh? Yeah, from what I'm seeing here, I guess so. Yeah, it did. Perfect. Because we basically gave it that, there you go. We gave it that example, so we nailed it. Right? So that's cool. You have already forgot about the compiler, where it is, because after the compaction happened, which kind of suck. But anyways. Anyway. Build clean, here's what was added. Clean up swap chain, destroys image views. Recreate with throttle, calls cleanup, create swap chain. Alright, does it work though? Well, let me make sure that we have some interesting color. Like, for example, red, let's say. And do we have any validation layer errors, though? I can't really tell. I think those probably are just like performance warnings, though. But anyway, let me just make sure at least it works. Yes, I think it does work. But when yeah, okay, so I guess it probably handles like 0 swap chain 2. Now, let me do one little thing here, which is to simply actually keep it, but we will only got like error. Let's just, for now, we're just gonna do this. So I could easily like see if there is some errors or not. There you go. There is a validation error when that happens. I get a validation error on swap chain being 0. Skip when width times height is equal to 0. Skip frame. All right. Also, another problem that it usually goes into, which is that when it skips, you kind of get into like a spin lock where it just keeps on like wasting CPU cycles for no reason. So we gotta make sure that it kind of like delays. Yeah. Now when minimized, returns early. No swap chain recreation, no frame drawing. Okay, let's see. There you go. Perfect. But hold on. Now if we go to the task manager currently, and let me see my Codachario here. Where's my Codachario? There you go. So as you can see, it's still like wasting a lot of cycles. It's pretty much just like going hard on my CPU there. Where's my GPU? Weird that it's 0% there, but anyways. So as you can see, it's a spin lock in the CPU. Actually, I mean, that's normal, that's good. But here we got, that's a problem. So we got a spin lock when that happens. Add some delay until add some delay, I think. I guess until an SDL event happens. And boom. I mean, I would have used, there's a cooler function than that, which actually blocks until an SDL event happens, but that should fix the issue that we currently have too. But yeah, let me show you. So, Codotario. So currently it's consuming 0.8 CPU. And when we do this, 0%. You see? So that's great. Perfect. All right, cool. Wait. Is that like part of this run or was it part of another run? Hold on. Let me just redo this really quickly. And now let me just see if there's any Vulkan errors or whatever. On program exit. All right, one other thing that I'm gonna make sure to tell it to do is to add debug names. So it would be way easier for me and for it to debug issues when they happen. Because right now, currently, we're just getting like these addresses, essentially, which kind of suck. Instead, if we set up that, we're gonna get some actual names, which is nice. So yeah, I think we probably still need to like add the in-flight frames, but we'll see. That's sick. So that's resolved. Now git commit and implement in-flight frames. Oh, it's already implemented. Okay, never mind. My bad. All right. Sorry. Okay, cool. So it's already implemented, actually. Yeah, I just noticed. All right, cool, lovely. All right, so now where are we gonna go next? Where are we gonna go next? So we got like the clear screen. Now I think, okay, cool. Now enable the dynamic rendering extension through the, what is it called? Vulkan 1.3 features struct. And swap the clear command with rendering command. Crap, it didn't use that thing that I've told it about. But anyways, I mean, that works just fine, but essentially there is some structs where you could like enable multiple features at the same time, depending on the version where it became core. But it didn't use it here, which is fine. But again, I think that's way better. Okay. All right, so build clean sick. Let's try now. And it still seems to work out just fine. No validation errors, which is lovely. And right now, I think we're using the vk-cmd begin rendering. Yeah, we are. So that's perfect. Lovely. All right, so what we're gonna do next is now add the debug utils in debug build. Wait. No, just to name and name all resources. No need for enabling validation layers programmatically, because I already use vk-config. Validation layers programmatic because I already use vk-config. All right. I'm not sure if what it did about that part actually. Did it like try to enable the validation layers? I'm not sure. Well, surprisingly it didn't, which is interesting. I mean, that's what I want, but usually all tutorials do that and so on, which is just useless. But anyways, unless maybe if, let's say, you're debugging in Android, for example, where you can't just use vk-config, But that's another that's another story altogether. But yeah. What the hell is that to object type? Bro, what? What is that? It's using, oh, it's using generics for some reason. What? I'm not sure what kind of sorcery it's doing with generics there. Wild. Oh crap, no. It's gonna like guard all of those. Bro, just guard the freaking debug name itself. No? Wouldn't that work? Not sure, but like that sucks, like having that sprinkled everywhere. Well, actually, like for example, SCD format is kind of sucks. Like if you would do it like all the time. Yeah, I'm not sure what we could do about it though. Maybe we could just like create some helper functions and yeah, in fact, that's probably what I'm gonna do next anyways, which is like create a few helper functions for a few things. So the code becomes a little bit readable. Right now we have like 800 lines of code, which is insane. Um, what? Wiki create device failed. It made the mistake, so it added it to the device extension and the instance extension, but it's only an instance extension. Bruh. But maybe it should add like some, you know, like debug kind of message to tell you which extension it failed on, maybe. But anyways, all right. So now git commit and add helpers so the code is readable. The main function should just be an orchestrator. Obviously, don't go over the board, or never mind. Let's just see what it's gonna do. Then I'm gonna ask it to kind of like cause some debugging issue, and let's to see if like how it looks like using the actual debug utils now. And it's actually quite good. like intermediate steps to actually like abstract this eventually. What the hell is going? Oh, yeah. Look at those staircases. Oh my god, bruh. Yeah, we need the exceptions, bro. Ain't no way. Ain't no freaking way, man. Look at that bullcrap. Either exceptions or you do like labels. The labels are pain in the ass too. But like FFmpeg, for example, uses labels for error handling, and like most production C code uses labels for cleanup. To make sure everything is cleaned up, both on like the error path and like the success path. But yeah, now let me also extract the rendering pass from draw frame. Wait, what the hell? Rendering pass? Oh, I guess maybe it just called it rendering pass, but it is like using dynamic rendering, right? Wait. I mean, it is like enabling the feature. But let's see, CMD. Yeah, it is actually using dynamic rendering, so that's fine. That's cool. Okay, so I wonder how's the code now. Let's see. So you got SDL app init. It calls init Vulkan, then creates instance, creates surface, pick physical device, create logical device, create swap chain, create command objects, create sync objects, and then you got the app iterate, draw frame, record frame, submit, and present, and then SDL app quit cleanup. Okay, so that's the quit here, cleanup, and delete state. And you got like SDL app event, nothing fancy here, just that. And the app iterate. And the app iterate, basically check if it's in foreground. Wait, what? If the app is in foreground, skip? How? Why? Bruh, really? That's weird. I should ask it that question, but we'll see later on. So if SDL delay, okay, so there is another function actually for this part here, wait. It's called wait event timeout, I think, or event, wait event, or whatever. Yeah, I think wait event. But we'll see about that. Anyway, so if state swap chain dirty, then if not recreate swap chain, then return SDL app failure. And then we got the draw frame function there. The app init, we create a new app state, then we try to initialize that stuff. If not init Vulkan, then return app failure and Vulkan pipeline ready. And the cleanup. Yeah, okay, so I have a few things here to say, though this runs correctly, right? This still runs, right? Right? Because otherwise, yeah, it still works fine. So here we create a surface, required instance extensions. We create, wait, in the create instance function we have create, bro, what? Really, Vulk initialize. All right, and then here we got like draw frame, which just does per frame stuff. It takes in app state. Okay, so it kind of just splitted the code, that's it, nothing fancy. Which is honestly fine for now, really. And like we got the record frame, which takes in the command buffer and image index. And then it records that part. Okay, sick. And then you got like a create swap chain. Wait, create sync objects. I mean, that's interesting. Clean up swap chain. It destroys the image views. It clears up the image views and images. And if the swap chain is not equal to vacate null handle, vacate destroy swap chain. Okay, and for every, yeah, it's interesting that it's like destroying. I mean, it's kind of good in some part because the swap chain could theoretically change some settings, which would need to like recreate all this stuff to some degree. But well, anyways, let's keep it anyway. I guess fine, maybe. But anyway, so here we got like for every frame. We set the debug names, I see. And finished semaphores resize. Yeah, that looks great. That looks pretty much great so far. And what it's doing here, it's using FIFO. Okay, that's fine. +1. Wait, it's hard coding the swap chain extent. No? Yeah, it is doing it here, bruh. Really? So basically in Wayland here, it would hard code it. But okay, fine. We'll see about that. Invoke Lloyd device, get device queue, sig. And yeah. All right, I have a few notes, obviously, and we'll see about them. I don't understand exactly what it did here. So kind of depends on which handle it is. It just picked. I feel like that's a bit over-engineered, or maybe I just don't understand what's going on there. But anyways, so all right. There is, you can check SDL API. There is a function that you can use to wait for an SDL event instead of just delaying and waking up the app every 15, every 10, or whatever it did there. I'm not sure if it's seconds or microseconds. Not seconds, probably microseconds, or no, I don't know. Milliseconds probably. Anyways, next up, also you're hard coding a window width and height. You should use SDL get window size in pixels or whatever it's called. And what else did I find out? Also, use exceptions. One for SDL. Or did it already use that though? I don't think it did. Okay. One for SDL and the other that just sets the message to SDL get error. And the other for what is it called? Yeah, for Vulkan, obviously. For Vulkan, just print the result code. Yeah, I think that's it for now. All right, just the initial plumbing pretty much. Okay, is there anything else it missed? I don't think, looking good so far. Reset fences. I mean, reset fences, for example, does return a vacay result, which is interesting. You should probably check for that just in case. Actually, you know what? Yeah, that's fine. Anyways, three change exception instead of bool return pattern, SDL wait event timeout instead of delay, and dynamic window size. This is a big refactor. I'll rewrite the full file. Oh boy, crap. Or you know what? Wait. Um, make a check function that checks the result code if it's less than vacay success, then it is an error. You can also get a default constructed SCD source location. Other than that, and then just throw if there's an error. That's that. All right, gee, let's go. All right, anything else? For example, this part here, we could definitely like use unique PTR if we want, but that's a bit of over engineering there. Other than that, I think we could move on to the next milestone, which is a triangle already. Actually, before that, we have to set up the allocator, the VMA allocator. And for that, I'm gonna make the AI agent read the documentation, and then it would do it, essentially. I mean, let me make sure if there's no git status changes things. Oh crap, okay, weird. Oh, there you go, okay. So no changes there. All right. Okay, so it rewrote the whole freaking file. I hope it's way cleaner now. I really hope so. Yeah, also I would tell it that it could just ignore the fact that if it's not null or whichever. And yeah, look at that, way freaking cleaner. Oh my god, thank god for exceptions. Cause what the hell in the world is that, bro? That's insane. That's insane. Let me make sure first of all this actually works now, because it changed the whole freaking file. which is a good and a bad thing at the same time. A good thing because, ooh, shit. Okay. Just crashed now. All right, cool. Lovely. How the heck do I... Okay, well, that's cool. All right. Resize into 0, 0, crash the app, or hang the app. Okay, let's see what it did. Did it understood what I told it or not? Okay, cool. It understood. There you go. It said lock is equal to current, right? And then it's using the std error. If it's less than vacate success, then it says Vulkan error at that, sick. And then they throw the Vulkan error, perfect. And then you got like check SDL. So print line std error, file name, throw SDL error. All right, that looks sick. All right, one thing, by the way, as I said, instead of this, we could use the Vulkan 1.3 features struct. Other than that, this is way cleaner than that freaking F staircase errors. It drives me insane. Anyway, I'm glad I don't have to write this code. I mean, C++ is great. As long as you don't have to write it, it's cool. It's pretty cool. What? What push event are you talking about? I'm not sure what it's talking about, but whichever anyways. Okay. Oh, what the hell? No, 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 not SDL push event, bro. I see what's wrong there. SDL wait event. You can just pass it null for the event to not consume it. Bro. I didn't pay attention. Let's see if that fixes it. Well, nah, it still hangs. But at least because thanks to the timeout, it kind of recovers. Oh man, no. No, it still hangs. Never mind, just use the delay. Sick. Alright, so alrighty. So we're just making sure that while the application is small and simple, we don't have any of these problems. But now I think we're ready to move to the next stage, probably. Yeah, I think we're ready. Commit. And what should we work on next? Let's see what it's gonna like suggest. Obviously, I still have a few nitpicks. Nitpicks, right? So there you go. Cool. It uses get window size in pixels. Otherwise, if you don't tell it, it would just use get window size, which is kind of wrong. I mean, it might work, but it would not be perfect in some other ways. But yeah, foundation is solid. Vulkan instant device sync right now. Just clear to red. Next logical steps: triangle MVP camera, block textures, chunk meshing. Plan out triangle. Tell me how you'll do it first. Yeah, these are very annoying, to be honest with you. I don't know if there is like a solution for that part. But yeah, the exceptions are way freaking cleaner. Oh, actually, before that, we gotta set up. Yeah, we gotta set up the VMA allocator. So where's VMA? Let's see. Am I still streaming, by the way? Let's see. All right, seems good. I think. Yep, we're still streaming. Sick. Okay, so let's see what we got here. Um, there you go. Quick start. Read the whole documentation. Doc starting from. Okay. 2 verge plus drag destroyed after pipeline creation. Set up just the allocator for now. First, then commit. Net new 2 shader files, 1 VMA source file, 200 lines of Vulkan code. Alright, so clean so far, man. Love that. So damn clean. Target include directories, Vulkan include there. I mean, since we're using Vulk, that's why it's using these. So basically, if you were like, you know, like linking to the Vulkan loader directly, you would just probably use this static Vulkan functions. Now add VMA to the main code. Okay. Check vacate create instance. Lovely. All right, there's also some other things I'd love to tell it. But yeah, now add init VMA, sick. So that's our buffer allocator. So instead of like allocating a new allocator for every single buffer, new memory and so on, that sucks. That's so inefficient. We're going to be using the industry standard allocator, which is VMA. Oh, okay, never mind. I see. So you just, wait, what? Weird, but whatever. All right, fine. So the build is already clean, huh? Well, that was fast. I mean, it's not much either, but yeah. All right. I mean, we could like check using API, but whichever. Anyways, so that's good. That's lovely. All right. What we're gonna do next now? Okay. So instead of enabling like one feature after the other using their struct, you can just use the bundle of Vulkan 1.3 features, for example. The other thing that I wanted is also, I think it's probably nope OP to call a Vulkan function, Vulkan destroy function using null PTR. Same with SDL, but check research if that's the case first, just to verify. Other than that, is there anything else I have left? I don't think. Also, verify that you're handling all functions that return errors. Look at that. Safe, but sets an error. Passing null to any. Expect to find safe and no. There you go. Lovely. That would simplify our code just a tiny bit, remove some stupid staircases there. Like, check this, if null PTR, if null PTR that, if null PTR this. Oh my god. Come on. It's compacting the context because it's got bigger. There you go. Right now, I just removed that thing and just added the Vulkan 1.3 features struct instead, as you can see. And in the Vulkan 1.3 struct, you could like enable multiple features at once that got promoted to core in that particular version 1.3. But yeah. All right, so that's lovely. Just some cleanup there. And look at that, much cleaner now. Much cleaner. All right, and it's done. Perfect. No problems there. How about SDL? It might have not missed some of them. Because like all SDL functions, there you go. For example, this one. Boom. I think you missed some SDL functions that can return error. I mean, it's not a big deal. Like, for example, this one, I don't think it would fail in like, but man. Oh crap, it wasn't checking for create surface? Weird. But anyways, there you go. And boom. Great. Okay, cool. Now commit and start implementing triangle. Start with no buffer, just hard-coded array. And let's go. So as you can see right now, it's just hard-coding the attributes for now, which is nice. So we don't have to bother with the allocator bugs if there's any. I don't think there is, but you know, just making sure we go small steps. So if any error happens, we at least have an idea of where that could be. And it's pretty much just using like CMake to compile all the shaders, which is sick. Pipeline layout, graphics pipeline. And the pipeline is huge. We're probably going to try to add reflection, so we don't have to bother with like creating the scripture set layouts and pipeline layouts and vertex attributes stuff and all sorts of crap. Like, so that would avoid a lot of bugs, and also save us a lot of lines of code in the main code. So like every time we change, let's say some vertex attributes in the shader or a uniform or whichever, we don't have to bother and like change it in the C++ code, and if it's wrong, then we're screwed. It just happens automatically. Now, obviously that's not very trivial to implement, but it should be able to do it. But yeah. Cool. There you go. So as you can see, build the proper pipeline for compiling shaders using CMake, which is lovely. That's nice. And as you can see, the actual triangle works. uh, it works. Git commit and add vertex buffer now. So you see, we go baby steps. Well, here we gotta use GLM. Yeah, not that. Gotta use GLM. There you go. We'll use VMA to allocate memory, then bind it to the vertex buffer, and you're good to go. And this is already way more efficient than a lot of tutorials out there, yeah, of Vulkan, and even little engines. But yeah. And we haven't used any library outside the Vulkan SDK so far, I think, right? Yeah, I think so. And there you go. Right now, I guess it's using like and it's nice that it's using these like asynchronous commands where it kind of like just starts some process in the background and then it could like stop it afterwards. When triangle now draws in the VMA with per vertex. Integrate GLM from the Vulkan SDK and use it everywhere you have a pair of width h or xy, etc., and vertex struct. And let's go. We gotta make sure that the call-in mode is actually like calling the back face. So if there's any problem with the, you know, the triangle winding order for whichever reason we catch it earlier. This is important for Vulkan, depth 0 to 1, because it's not like OpenGL, which I believe was like -1 to 1. But like if you're using GLM with Vulkan, you gotta make sure to add this one. But yeah. Times 4. What? Weird. Um, okay, so we're good now. Lovely. All right, so what was that exactly? GLM, right? Yeah, okay, cool. So this is GLM. Did we add? No, we haven't. Add index buffer. Let's go. So those obviously should be bundled together, the allocation with its buffer. That works. Now read the whole code and tell me what's repeated that we can abstract into functions at least, or bundle into struct. So this is your index buffer. And we've came a long way. Shader module creation: two identical blocks. A vacant create shader module. Helper eliminates the duplication. Count, then fetch. Same query count resize fetch pattern. Would clean this up. Clean up versus clean up swap chain redundancy. Go ahead. Now add create buffer helper after any VMA. Now simplify record frame to use the helper. Okay. Right, so after this, I think we should be ready for a cube with the camera. Camera. Well, actually, before that, we gotta add the depth buffer. Yeah. But we could, like, probably just do it in one step, honestly, at this point. I don't know. Create swap chain. I mean, a lot of what I've done so far, I could have done it in way lesser time if I've just done it in one step. But like going through this little step by little step, make sure that we maintain good code quality essentially. Here's the summary of instructions. Okay, cool, lovely. All right, so now plan out how you'll implement a cube. So here it's just finding the program GSLC, shader dir, shader ouch, make directory, shader sources for each shader. It gets the file name component, add a custom command, and boom. Sick. Hello. Hey, yeah, it is JetBrains Mono in VS Code. Replace the flat triangle with 24 vertices, 36 indices, uniform buffer objects, MVP matrix, model view projection. It should also add translation for later on. Needs per in-flight resources per frame in-flight, one per frame. Wait, for MVP it could just use push constants though. Yeah, for MVP we could probably just use push constants, I think. Or should we though? Wait. Uniform buffer memories, uniform buffer mapped, new app state members. Oh, it's gonna create the descriptor set layout, descriptor pool. Hell nah. Hell nah. Yeah, crap, no. Create pick support depth format or fallback. Nice. Stored in app state as depth image view, and depth image memory. Needs a transition image layout call. Vertex shader. Okay, nice. Fragment shader in changed. In SDL app tray, before record frame, compute the model matrix, compute the view matrix, and the projection matrix. And mem copy. Sick. Also destroys. Can't we just use push constants, or should we keep the limited push constants for other things? Otherwise, would push descriptors help? Because, okay. Good question. Let me break it down. Push constants. MVP. Guaranteed minimum is 128 bytes. Tier supports 256. No descriptor sets, no buffers, no pool. Just simplest path, 0 boilerplate, best for small per draw data. Uniform buffers needs layout plus pool plus sets plus 2 buffers plus persistent mapping. Overkill for 192 bytes, but scales to arbitrary data and is the standard path for per frame data. Push descriptors eliminates pool sets but still needs buffers plus layouts. Middle ground that only pays off when you have many descriptors to update. Not worth it here. Recommendation: push constants now, they're perfect for MVP. If you later need more than that per draw, you migrate to a uniform buffer. That's a small refactor, not a rewrite. The plan layout change is one line either way. Yeah, go with push constants, please. Oh my god. Also add the camera translation too, because we'll need it later on. Am I not right? Yeah, I believe there is some other things later on which would need the camera translation component by itself. Yeah, specular, there you go. Like Fresnel, Skybox, etc. I mean, it would be way smaller to just like basically multiply all those matrices and the CPU and just push them to the GPU as one single little matrix. But then you lose out on that, on the granularity, which you're gonna need to basically be able to seamlessly jump between coordinate spaces, like between local space, world space, clip space. You got the point, right? Because like if you don't have those individual matrices, then you'd have to like invert and do all sorts of weird stuff in the shader, which might work, might not work. And even if it does, you would be paying in performance in compute cost. But yeah, all right. It's using Alinus, interesting. Right, cool. Cool. Love this so far. What I really love about Vulkan, it's so consistent. It's like the most, although it's very verbose, you know, very freaking verbose. Oh my god, insane. But other than the swap chain part, it's very consistent API. And the tooling is amazing, perfect. It's like you got vk config, you got validation layers, you got, it's just amazing. Honestly, it's such an amazing experience once you get over the first hump of the setup and all that bull crap. But yeah, that's why I took it very slow in setting up this project at the start. And even then, now I'm still taking it a bit slower, because like if you got a good start, then you're good to go. But if you got a bad start, you're gonna pay costly later. Especially for Vulkan, because there's just a lot of moving parts and a lot going on at once. So yeah, I'm trying so far to avoid making classes for everything. If you've noticed already. But yeah. Right. Now the plan that I have is that once we have a more complex stuff going on, then we could start like abstracting from the patterns we found that we're gonna need. We can start abstracting. We start by abstracting a little few helper functions, and then later on those helper functions could potentially be promoted into actual structs or classes or whichever. That's the way I intend to go with. Yeah. All right. So Next, I think we might try reflection, shader reflection, so we don't have to constantly like specify the, you know, the layouts, the push constant layouts, etc. That sucks. Or maybe I should keep it until later. I'm not sure, honestly. We can ask the AI and see what it would be, its thoughts. That would be cool. But other than that, afterwards, what we should implement? I mean, I have a lot in mind. I'm just not sure if we should start like abstracting already or not. Probably not a good idea. Maybe I should just keep everything in one file. Call it a day. Because, man. Now add time tracking to app state and compute MVP and SDL app reach. Time tracking? Why? What it needs time for exactly? Maybe a rotation? Yeah, probably a rotation. It's probably gonna rotate depending on the time. Yeah. Cool. Cool. There you go. Look at that time. Now build and run. And boom, we got a queue. Look at that. Cool. Was there any like validation errors, by the way? I'm not sure. I guess we'll have to find out ourselves. There is some validation errors, huh? Yeah, synchronization errors. We still have validation errors, I think. Now the session is getting compacted again. It's gonna run it again. And I guess we got no validation errors this time. Right? No, we do, I guess. No? Actually, no, we don't. But yeah, that objects defenses. Why are you recreating sync objects, etc. when swap chain resize? It's too heavy. So git commit first. Yeah, that sucked. So it's gonna split it now. I mean, there is a caveat though, but it's highly unlikely. It's basically if the image swap chain images count changes, then yeah, it does need to include, like, create more, for example. But that's usually probably not the case. Okay. This is fun. Now I see the full picture. So independent of swap chain or resize. Yeah, there you go. Practically never changes on the stop resize. And let's go. Now let's see if there's any validation errors. I don't know, it still feels jarring, but maybe a bit better anyways. All right, cool. So now we're gonna tell it to now create a chunk of 16 by 16 by 16 cubes and position the camera, well, to see them. Also make the colors, or never mind, let's just see what it's gonna say, what it's gonna do. I didn't even tell it if it's gonna use instancing or what exactly. I just want to see what it's gonna do. But yeah, so clean. So damn clean. Alright. Alright. Window, instant surface, physical device. I mean, practically this part right here is just like the context, kinda. Then you got this part for the synchronization and frame stuff. Oh crap, we hit the free limit. Oh boy, now create a chunk of 16 by 16. So I guess maybe we're done here. All right, how much time was it? Yeah, like we hit the free limit in 2 hours and a half. But that was a pretty clean code, not gonna lie. That was pretty. So I guess we'll keep the stream short anyways. So it's watchable. But yeah, we got a pretty clean code base, honestly, out of this. We could have done more if we were faster, but look at this. All right, anyways, so we're gonna, I think, like, I could publish this publicly. This is obviously gonna be open source. Public repo. I do accept though like commits from AI, but just make sure you review it yourself, that's all. And obviously you wouldn't like just commit like 5,000 lines of code at me. But anyways, sign in with your browser. Yeah, hold on a second. And there we go. So right now it's pretty much published. You just put up star there, and let's create a little license for anybody who's concerned. I don't freaking know. Go with MIT, I guess. I just choose a random. Anyways, let's go. And we'll probably vibe code the readme later on, but I think for now we should be good to go. All right, so this was it. Thank you all guys for coming to the stream, and see you the next one. See you tomorrow. Goodbye, everybody.